Yes, we are okay.
We are okay to start.
Yes.
Okay. Am I allowed to share my screen?
Yes, please.
Sorry?
Yes, yes.
Okay. Am I sharing?
Yes, you can see it.
Yes, you can see it. Good afternoon, colleagues. Good morning, good evening, depending on where you're coming from. Welcome to yet another edition under the ACRA program. And we agreed as Blue Forum, as a partner in the ACRA program, that we shall be able to bring to you the different facets of climate smart agriculture and climate information systems. Today, we have a seasoned researcher who will be giving us climate information basics and climate information basics, and ordinarily would have been the core, the first session that we had. We have had other programs that we have looked at. This builds into that, but also gives foundation to the different course modules that we have been having under the ACRA program. ACRA is a program that is looking at accelerating climate smart agriculture across the African continent, looking at what the CGIAR technologies and the different facets of climate smart agriculture and climate information systems. Dr. Tufa Dinku is here as a senior research scientist from the International Research Institute for Climate and Society, commonly referred to as IRI, of the Columbia Climate School. He has more than 3 decades of operational research experience in the field of climate science and its applications. He has been contributing to the use of science for society through development and implementation of the transformative ENACTS, which is Enhancing National Climate Services Approach. I'm very excited that Dr. Tufa, I always call him Dr. Tufa, not the Dinku one, will be able to give us what will drive what we do in our respective course units, in our respective courses, and in our respective universities. Please pick all those aspects that you would like to apply, whether in your dissertation, whether in your research, whether in your teaching. And we shall be glad to receive feedback even as we go along. Dr. Tufa Dinku, you are welcome to the Blue Forum community, and we are excited that you'll be giving us your knowledge on climate information services, as it were. So welcome, and please, the floor is yours. Thank you very much.
All right, thank you, Florence, for that very rich introduction. Hello, colleagues from everywhere. So I think we will be together for the next couple of days to talk together about climate basics, what here at IRI we call climate literacy. So to provide you with the foundation. So before I go into any slides, this should be interactive. I mean, I don't like remote training. I think Florence knows this. I want to interact with people. I get energy from people, but this time I will be talking to myself in a small room here in New York, but that's not ideal. But so let's make it as interactive as possible. And this is because this is climate basics. You can ask any basic. This assumes you don't know anything about climate, but that's not true. I know many of you even might be teaching climate yourselves, but even you, those who know about climate, you will learn a couple of things. One, maybe you might learn a couple of new things. If not, at least you may learn how to simplify some of the concepts, hopefully. So again, it is climate basics, it is climate literacy. As Florence says, this is so that you either you can use the concept or the material or the knowledge for yourself or in your teachings. I will share the slides later on with the Forum team, but also there is an accompanying reference guide, which again we will share. So don't worry too much about taking notes. Just try to follow and be active. So I will go every day. So we'll do it 2 hours, but we will have 15-minute break between the first hour. So we will do like maybe 1 hour, then 15-minute break, and then do another 45-minute. Okay. So that is so anything else anybody want to say from the Forum side in terms of, before I go ahead into the slides? No. Okay. All right.
I think you can go ahead.
Mufo, I think Lawrence has already given a brief overview, so you can proceed.
Okay. So let me see if I can share my screen now. Share my screen, this one. I need to maybe remove the video as well. Take the video. Maybe don't need video now. Save space. Okay. All right. Now, do you see my screen now, everybody?
Yes, we can see, but you have to maximize. It is in a small.
Okay, let's see what it's.
You use the presentation. Okay. Now it's okay. It's okay.
All right. So first, let's start with the overview. I want to provide some some background before diving into the concepts. So again, the objective is, like I said earlier, to provide some basic concepts in climate knowledge, so that you have some foundational knowledge, or you can use it to provide some foundational knowledge to your students on understanding and using climate information and the service. So the whole overall idea. So some background about myself. So Florence has already introduced me. I'm from IRI. IRI is part of Columbia University, which is located in New York City, but actually Columbia University has another campus outside the big New York City. So yeah, that is what you see is my office. On the right side, the IRI, and you can see the mission of IRI as well. I think just to say, to enhance society's capability to understand, anticipate, and manage the impact of climate in order to improve human welfare, especially in developing countries. So that is the overall mission of IRI, and that is why we are doing what we are doing today, which is part of the curriculum I will tell you about. So IRI, it is about climate and society. So we have a climate side, that's where I come from, but then we have also society side, agriculture, health, different sectors. And as you see, we work in Africa, Asia, and Latin America, South America as well. So the training, this is part of another curriculum. I think Florence alluded to that before. We have an extensive curriculum on climate risk management in agriculture extension, CRMAE, which is a 2-week curriculum. And in that 2-week curriculum, the climate basics part is 3.5 days. So with exercises, questions, group work, all that. But we cannot do all that in 4 days, 2 hours a day. So this is for you to understand. We will be almost summarizing, so we wouldn't have the time, for example, to do some of the exercises that we normally do when we do this in person. So I mean, I don't want to go to the list, but you can see what the whole idea, the whole curriculum is skill-based, of course, knowledge. So the climate basics, the knowledge part, but also skill and attitude part. So the climate module, the climate CRMA has these 4 modules, and you can see the climate basics in the first module, which is the foundation for the other modules. And then module 2 is about climate information. You can accent use. Module 3 is climate sensitive agriculture, which is what's the relationship between climate and agriculture. And I think the last part is how can you use climate information services for improved decision in the agricultural extension system. But we say extension, but actually it goes up and down in the system. We have also, so we have for that, we have these materials. Again, I don't want to go through, but reverse guide, which is over 200 pages, and other materials for that one. But we have also, so this
sorry.
in Ethiopia. Yes.
I think your volume is a little bit low. Maybe you can increase a little bit.
What about now?
Yeah, maybe, yes.
Can you hear me now? Okay.
Yes, we can hear you.
Okay. It's because I'm dancing around. Sorry, I'm not dancing around. So the curriculum started in Ethiopia, but then now being implemented in other countries, the countries you see here, through ECRA project extension curriculum. We have also started a university curriculum that we started in Ethiopia now. And now you see it has, instead of 4 modules, so now it has 5 chapters. There are a lot of differences. From the climate side, the difference is chapter 2. In the other curriculum, module 2 is just about climate information, so the accessing and using climate information. In this case, actually, it is about accessing data and generating your own information. So it includes, I will show you later, some tools you can use for data analysis and visualization, that kind of thing. But of course, also if you want, it also includes a readily available climate information program. So this has started, and this is mostly for last year university students or graduate students. It is very involved. Again, this has so far been implemented only in Ethiopia. So the climate basics, if you don't mind, let's go now into this one. These are the main areas I'm going to cover, hopefully, over the next 4 days. So the basic concept first, some definitions, and then what makes the climate of a location, why is the climate of Ethiopia or Ghana the way it is, what are the main factors that affect this, and then climate variability, how does climate vary from year to year, and why it is varied, why is this one year El Nino, another is La Nina, and what does that really mean? Talk about climate data and information, what's the difference, and some ideas about analysis, climate data analysis. Then we'll touch climate prediction and projection. This is not for you to do climate prediction or projection, but just to understand the approaches and the methods that are used. Finally, we will finish with climate change, talk more about climate change at the end, hopefully on Thursday. So far, any questions so far? Anybody with any question or point to make from what I said so far, especially from the Forum side? No? Okay.
It is fine so far.
So far, it's fine. Okay. I like fine. So, I mean, just an overview of what we will be covering under each component. So under basic concept, we will talk about what is weather, what's climate change, what's climate variability, what are the components of climate, and then the spatial, because climate has both spatial temporal component, and what are those. Under 2 is those factors Number one, how do you actually describe a climate of a location, right? I mean, what are the things to look at to say, this is the climate of this place? And then look at global and local factors that define a climate of a location. Into variability, this is mostly about El Nino, La Nina, Indian Ocean Dipole. Those are the ones, there are many of those, but they're the ones that have impact on climate in Africa. Talk about climate data. What's data? What's information? Where do climate data come from? What are the types of climate data? What climate information types? And then maybe a slide on climate analysis. Just what kind of analysis we do, basically. Not complicated analysis, but just to say what is average, what is this, what is it. Then we'll talk about climate prediction projection. So what is weather forecasting, how it is done, what's the difference between weather forecasting, climate prediction, climate change projection, those kind of things. And then finally, we will talk about climate change. What is it? What causes it? What are the impacts? And what are the scenarios we always talk about? And actually, what's the difference between climate change and climate variability? Because many people mix up those things. So we will try to see what differences those are. So that's it in terms of the overview. If there are no questions, then I will go to the first part. But if there's any question now, you can ask any questions in terms of our approach. And if not, we will dive into the climate basics, the first concept. So let's try to cover as much as possible. Everybody okay? You hearing me okay? You can follow? Am I too fast, too slow? Anybody want to complain about anything? No? These are very nice. How many people do we have? Oh, so we have 99 plus no, it's 99 plus. Over 230 very nice people who don't want to complain at all. Okay, thank you. So anyway, let's go into the thing. So by the way, if you want, because I cannot see if you raise your hand, most probably. So either the Raw Forum team can pick people who raise their hands. Otherwise, you can also say, I mean, I see a lot of thing in the chat, but I'm assuming that is just introductions. Okay, I mean, the challenge with this remote training is I cannot see what people are doing. So let's assume everybody is following very attentively. Okay. So it is me and of course Sylvia who has contributed a lot to this slides as well as all the materials we will share with you. So the first one is, like I said, this basic concepts. Here are the high-level objectives. Say something, what's the difference between weather and climate? What are the components? Basic meteorological instrument, I think that many of you already know. So for agriculture people, I mean, this is not that necessary, but also what is spatial and temporal components of climate. So here is what is weather and what is climate. So for me, I would like reaction from people. Anybody who want to say what is climate, what is weather? You can just type into the chat box. What is weather for you? I mean, how do you understand weather? How do you understand climate? What's the difference? If you think there is no difference, then you can say, okay, there's no difference. So I will give you next maybe 3 minutes to write into the chat box what do you think weather is, what do you think climate means actually, what weather means and what climate means, and what the difference between the two. Go ahead. Manuel, you've been in this training before, maybe that's why. So weather is the condition of the atmosphere at the short, okay. Weather is what we experience when you set up and given the climate average. Yeah, was this one? Okay. Weather is based on a short duration of climate is the average change. There is a day to day. Okay. I see some people who already been in this training before, so that it could be boring for them. Whether is an aspect in what? Climate is equal to atmospheric condition. Climate atmospheric conditions. Okay. Very short answer. No? Climate is equal to atmospheric condition. Whether a state of atmosphere at a particular place. Weather. Okay. Climate is the over a period of 35 years. Somebody says 35 specifically. Whether it's a day to day. I think they are a good understanding. Some of them exactly what I have on my slides because I think they have seen it before. The short-term atmospheric condition. All right, so I think it's enough. For me, I like this one, which somebody already said before. Yeah, so somebody has already said this. I mean, I like how it is put here. Climate is what we expect and weather is what you get. I always use this definition because it seems to make sense. For in a, I don't know, in West Africa, what's now? It is September, so it's end of the season. So wherever you are, there are what to expect for a month, for September. You think September in Ghana or Kenya looks like that's what we expect. But if you go out and feel the weather, see the weather now, outside, that's the weather. That's what you see. That's what you get. So it's a good thing what to expect, but that's what you get. So, and of course, the weather is what you see on the TV. People telling you next days or 2 days, 3-day forecast. That is not a climate forecast. That's a weather forecast. And I think somebody put already this state of the atmosphere at a given time and place. I think that's a specific time and specific place, and that time and place. It is a very restricted time, next few hours or next few days. That is the weather. And of course, I mean, you take your umbrella out for the weather, not for the climate. Anyway, I don't want to go through the list, but it's just to say climate is next season when you say the rainy season is coming. So you are actually talking about what to expect this rainy season. But if the rainy season comes and on a given day on the rainy season, it might be raining or it might be totally sunny. That is the weather. Climate is again, now it is, like we said, it's what we expect. What we expect means it is the average, it is the mean. Somebody says 35 years, but actually it means the World Meteorological Organization, WMO, the recommendation is 30 years. So the last 30 years, they update the climate period, the climate window, they update every 10 years. So for now, for this period, the climatology, the mean we use is from 1991 to 2020. So that's 30 years for the climatology for 30 years. And the climatology also we use as a reference when we look at things that being as expected or not expected. So I think the last point, the same climate tells us what it is usually like in the place where we live at a given time, but weather is actually what happens actually. So now if you know climate, then climate variability is the difference between that 30-year average and what we call climatology, and what happens in a given season or a given month. So if you have my monthly rainfall, not monthly, but seasonal rainfall, so this is like year-to-year variability. It could be year-to-year variability, what we call decadal variability. But it defines the difference from the average state, means that 30-year average of the climate or climatology across temporal and spatial scales. And temporal means could be at monthly time scale. So at monthly time scale, comparing this month's, let's say, rainfall temperature to 30-year average, or these seasons or this year's, that kind of. There is also WMO, formal definition of what variability is. So the deviation of climate over a given period of time, again, the same thing, but we said again, when compared to long-term statistics. Again, so in here, when there's a long-term statistics is not just the mean. So long-term statistics mean many different things. We will come to that later. But mean is just one of those. So that is climate variability. Here is an example from Zambia. This is seasonal rainfall anomalies for December-February season, which is a rainy season for Zambia. So this is part of Zambia that is painted in red. So this is from 1981 until 2020. So this is seasonal total rainfall compared to the mean, compared to the climatology. So the 0 is, of course, this means climatology and what happened is the same. And negative values means the country or that region experienced below what's expected, and green means that region experienced above what is expected. So you see, like in 1992, you see like it was very much below expected, most below what by 200 millimeters. But you can also see some wetter than expected years. So this is just an example of climate variability. Okay, changing. This is changing from year to year, but for a specific season. We can do the same thing. Instead of looking at season, we can also look at the given month and do the same thing as well. So climate change, I mean, like I said, on Thursday, we will come back to in detail defining climate change. But because we are talking just about concepts here, I want to also include some concept or definition for climate change, the way we see it. So I think the main thing is change in the characteristics of the climate. That's one thing, change in the characteristics. So that characteristics could be different things. Again, we will come to that. So the average is just one of those characteristics, but not the only one. Extremes and other characteristics, like you flooding cyclones or dry season, wet season. Those are also characteristics. So it is a change in the characteristics of the climate over a very long time. Remember, so if climate, we define climate as being a 30-year average. So if you want to see the change, then actually that would be really long time, actually over a long period of time. So you cannot say it is climate change because it was flooding last year and drought this year. That doesn't mean it is climate change. Climate change, you have to see trend over long period of time. I think an example again from Zambia, you can see some trend in the temperature. You can see the gray lines representing climate variability from year to year, right? And then the trend line showing some sort of climate change over over 40 years of the 50 years period. So those are the basic concepts for weather, climate variability, climate change. Now, is there any question on that one? Any questions, comments, complaints, if there is any complaints on what we covered so far? So I cannot see the hand, so maybe I can share. If the forum team can help me. Any questions about those concepts?
Yes, there is a raised hand from is it Gabriel Kiros? Gabriel Kiros, you can go ahead and unmute yourself and ask your question.
Yeah. Thank you, Dr. Tufa, for your very interesting presentation. I do have one question which is not clear for me from.
You're a bit low.
Yeah,
Kindly
okay.
speak up.
Okay. But I'm not clear about climate anomaly. What's climate anomaly?
Okay, I think that's a good question. Actually, it is my fault. I should have explained that concept. So, by the way, anomaly means what in medicine? Something is anomalous means something is not normal, right? So in meteorology, remember the mean, the 30-year mean, the 30 mean average. That is also called a normal. The 30-year mean, the 30-year average rainfall or temperature, that's the normal for that location. So if something is different from the normal, that is anomaly. So actually anomaly is just the difference between what happened and the normal. So the graph I show, these ones here, these are anomalies.
Okay. Deviations.
Yeah, it's just the difference between
The deviation from the norm.
exactly. It's the deviation from the normal. That's anomaly. Thank you. It's good actually to ask questions.
There are more two hands. One from BDC, Mohammed. Please unmute and ask your question. Mohammed, please go ahead and ask the question.
Okay, the question is, there are some terminologies such as climate variability, climate change, weather fluctuations. So regarding to the previous slides that you were explaining, if there is a climate variability, we know the word climate variability, but in some areas you can see weather variability. What's the difference between weather and weather variability? And the other thing is, when it comes to climate variability, it's based on seasonal or less than decades or years compared to climate change. Thank you.
Okay, this is again another good question. So people talk about weather variability. So I think sometimes people use weather variability to mean climate variability, but there are totally different things. I mean, weather, by the way, weather, by definition, weather is variable anyway. Because what you see now will change in about an hour or change in about the day. So talking about weather variability in the sense that we talk about climate variability doesn't make sense. So for me, again, just to repeat what I said, weather by definition changes from hour to hour. I mean, it could be sunny now, it could be cloudy in 5 minutes. That's the weather change. So the time scale is really very short, the weather time scale. But the climate time scale, remember I said the climate time scale is longer. We are saying, okay, what's happening in terms of compared to 30 years. So in terms of now coming to climate variability, remember we said when we defined climate variability, it says defined across the average across temporal scales. Across temporal scales means across time scales. So I can say, okay, 2 days, if I have measurement for temperature today, let's say 25 degrees, And I can compare it to the 30-year average for today, but today is what, September 24th, right? For September 24th. So now I am calculating a daily anomaly. So it can show you the daily variability compared to the same time in the mean, in the average. You can do that at monthly time scale again. You can do it at seasonal time scale. You can do it at annual time scale. And even here, you can even do it at what? Even decadal. Decade means 10 days. 10 years time scale. So you can compare a given 10-year period compared to the previous 30, average of the previous 30 years. So it is different time scales. For us, in terms of climate information, we normally talk about the seasonal average. Here, for example, what we see for Zambia, you see it is December, February rainfall for each year, the total December, February rainfall for each year compared to the 30-year average. Okay. Is that clear, Mohammed? Did I answer your question?
I think is now okay. There are more raised hands, but also maybe you can check when you click under Q&A. There are many questions which have been written there. It's a dedicated
Yes,
section
yeah, but
for questions.
I don't have time to. What is the?
Yeah, when you click on Q&A, you are able to see the questions which have been raised there.
Any difference between weather and climate extreme events? So I mean, later we will come this question about from Sentayo, any difference between weather and climate extremes. So when you talk about weather extreme, you are actually talking about climate extreme. Why? To say a weather is an extreme, an event is an extreme, you have to compare it to something, right? I mean, what happens today cannot be extreme unless you compare it to what is expected, to the climatology, to the normal. So when you are talking about weather extremes, because of that, actually you are talking almost about climate extremes as well, because it doesn't have to be, like I remember daily, the anomaly, you can calculate daily anomaly, weekly anomaly, monthly anomaly, seasonal anomaly. Yeah, so that can happen. Kentin, considering the long-term climate data, is climate change the change between two normal or the change? Okay, this is another good question actually. So when we say climate changes, is the change from one normal to another? Yes, but also it could also be extremes, right? I mean, if the extreme condition, if the drought, for example, over long years, if the drought is increasing, that's climate change. If the flooding is increasing over the years, that's climate change. I think we will come to climate change later, but that's one thing. So the last one is Maza. What happened? Where is Maza's question? Okay, thank you. How change in season can be considered as climate? No, I didn't say. Yeah. I mean, if the question, again, I think let's keep the climate change question later because we will come for that. But yeah, I mean, if the length of season, for example, changes over years, that could be climate change as well. So we'll come to climate change. I mean, that's why, by the way, this concept, understanding the concept, starting the concept is very important. Okay, so I wouldn't have time. Yeah, I think I have answered some of them, but let's go to the next level. Okay. So here is the question for you, just as a teaser. So the question, the thing is, which of these statements here are either weather, talk about climate, or talk about climate change. So the first one, it says in a given day, 2020, there was this much millimeter in rainfall in Lusaka. So is that talking about climate, weather, climate change, climate variability? Can somebody tell me? Yeah, you can put it in your Q and answer thing. Is this climate or weather, climate change? Can you just into the Q&A? Okay, see weather, okay. All right, so it seems that everybody is saying weather. Yeah, because it's a given, this is a specific day. So yeah, it's definitely weather. That's a good thing. Now, what about the second one? It says flooding is more and more frequent in Addis Ababa. Is that weather, climate, or climate change? Go ahead in your Q&A. Climate, somebody's called Amdom says climate extreme. Yeah, but I said you have to, so whether it's climate change, climate variability, or weather. Climate change, somebody's climate change again, Gabriel. Anybody else? For number 2, climate extreme. So the other 200 people don't care? Climate change, okay. Climate change. Climate change. I mean, it seems like I see a lot of, okay, Godfred says what? Climate variability, climate change. So, this is a little bit tricky question because it says flooding is more and more frequent. There are 2 issues with this one. Number 1, it doesn't give you the time scale. Like over the last 3 years, 5 years, 10 years, 100 years, it doesn't tell you, right? So it's hard to tell. Number 2, and the main thing is flooding can happen even without increase in rainfall. Do you understand what I'm saying? Flooding, the cause for flooding is not just rainfall. Anybody disagree with that? Because flooding in Addis could happen because of construction, too much construction. Could happen because maybe sewage system is not working. Could happen many other reasons. So this is not just about climate. It is about the built environment, about many other things, okay? And Godfred seems to agree with that one. Okay. The number 3, the rainfall in for record in Dakar on a given day was the third daily, what was the third largest daily amount on record? What is that one? Climate change, climate variability, weather. Go ahead, anybody. Your answers. Number 3, what is that? It is weather, extreme event, weather. Okay. So by the way, this is goes along with I think it was Muhammad Ahmed, the question he asked earlier, and my answer to that. Weather variability. There's no weather variability. We say the weather variability doesn't make sense. It's mostly climate variability. Weather is variable anyway by its definition. So. Okay, because it says it was the third largest, but yeah, third largest compared to what? Again, it has supposed to be. It assumes there is a series of data, which means over many years. So I think maybe climate variability. It's more about climate anyway. In general, it's about climate, not weather. What happened is the weather in one day, but here he is comparing what happened to what is expected or what happened over the last many years. So more about climate and climate variability. I think the last one is very easy, right? Because it gives you the frequency of daily rainfall exceeding 100 millimeters in Nairobi has been steadily increasing over how many years? Over 50 years. I think this must be very obvious, but what do you think it is? Weather, climate change? The anonymous is 100% sure it is climate change because he or she puts that in all caps. How come? Where are other people are? Climate change. Anyway, I mean, this is, I mean, telling you over the last 50 years, and this is the long period we're talking about. This is actually the definition of climate change, you know? All right. So any other question now, before I go to the next one? Assuming no? Okay. So how do we measure climate? I think so. We are talking about climate, right? How do we observe climate? How do we measure climate? I think one way to observe, the simplest way, maybe, to observe climate is to observe the environment, right? The vegetation and the activities people do all depends on climate, right? Now, if you look at these pictures from left to right, you can see what the first one, you can somebody with a camel in a very dry area. So you already have some idea what that climate is. The next one, and maybe the middle, not very easy to know, but I think you might have some idea at least. They are growing something over that area, so you can guess what the climate might look like. But and the ones with the sheep, again, sheep with that amount of fur, you can guess, okay, why they have so much fur, so it must be cold, so the climate, this one. And the last, again, is obvious, you know? It is somewhere where there's a lot of snow. So again, you have some idea about climate. So it's same, the environment itself can tell you about climate. What is this? But also there are things we measure actually. So we don't do climate just by looking at the environment. There are things we measure, which are what we call the weather variables or the climate variables. I think all of you are familiar with this: temperature, rainfall, pressure, humidity, solar radiation, wind. All these are how the different components of the climate. So you want to measure how much rain is coming. You want to measure what the temperature is. You want to measure, okay, what the pressure of a given location is. You want to measure what is the solar radiation coming in. All those are the different components of climate. And these climate variables are measured around the world every single day. And I think the good thing about the climate data is they have standard across the world. I think this is one of the parameters or the observations that are well standardized because of the World Meteorological Organization. Rainfall is measured at the same time during the day. So because the rainfall measured in New York will be used in Addis, and the one measured in Addis will be used in Bamako, because for weather forecasting, we'll see later, you need data from around the world. So if you do that, the data should be able to talk to each other. So because of that, and the measurement of climate component can be, once you have then the data, then you can express the data, right? It's not just looking at the numbers, but those numbers can give you information. I think we'll come to that either later, but extremes, right? You say, okay, it is higher than expected, lower than expected, hotter, wetter. Categories, remember the tropical storms, category 1, category 2, depending on the wind speed, strength, thresholds, like above this threshold, below this threshold. Frequencies, how many times something happens. Accumulations, how many millimeters of rainfall or how deep snow. Actually, the snow doesn't apply to Africa, but still. And of course, averages, which we've been talking about. Again, I don't want to go through this. Again, I'm just assuming many of you are all familiar with this. So these are the different instruments. We use those: thermometer, rain gauge, anemometer, hygrometer for humidity, a barometer for pressure, the parameter for solar radiation, and many other things. Wind, anemometer or wind event for the direction, and the meteorological stations. We'll come to this, put all this together. So that's what station constitutes on the right side. So another thing is weather, I think, and climate. Climate has both spatial, means space component, spatial component, and temporal, time component. So when we say a spatial component, is when we describe how climate varies in space, which means how climate varies from one part of the country to another, from one location to another. So when you describe climate in space, it means time is fixed. For example, the picture you see here is the December-February average temperature for Zambia. It's average maximum temperature for December-February season. So you can say most northern part of Zambia is in the blues, which means colder than the southern ones, which is red, which is very hot. So now you're talking about, it's fixed the time because it's a given season. But now you are looking into space, how these values across Zambia. It could be across any other country or a continent. So the point is fixed time, but varying space. The temporal one is, again, different. Now, again, looking at the Zambia. So the first picture shows temperature is a minimum temperature. So the bars represent temperature in degrees for the difference from January to December. So this shows temperature seasonality, which means now it is fixed. This is for a given location in Zambia. Okay, you extract for a given location, or maybe you can do it the whole average of Zambia. But now it is, when you look at variation in space, it means, no, in time, it means the space is fixed. So in this case, a location in Zambia, now you see in what we call seasonality. In January, it's very relatively hot, and in June, it is cold. Or the lower graph shows you monthly rainfall from 1981 until 2021, 2022. So longest time series, again, how rainfall over a given location been varying over the last 34 years. So just so that you have some idea about the variation in space and variation in time. All right, so before we have our first break, any questions? Any questions we have before? Or any comments? No? Let's see if there are any questions here. Will handouts be shared in our emails? Yes. I think Ruforum will have an online portal where you can go download this presentation as well as a document that we are putting together.
That's true.
Any questions? What are the major risks for climate change? The same thing. I mean, from the climate side of things, the same thing. Brukayela, thank you. You're saying this is smart lecture. I don't know what smart lecture means, but at least sound is positive. Yeah, thanks. Any other comment, questions? What is Grima talking about, everyone? This video clearly expands this question for, I see, okay.
Sefa, Girma, do you have any question? I see you have raised a hand. Girma, Sefa, you can unmute yourself if you would like to talk.
So I see from who is that? Stanley, who says a great presentation. Learning these basics is quite intriguing. Okay, particularly what's that? Come on. How we take this? I mean, that's a good point, I think, Stanley. Yeah, but many people we think we know and we take it for granted when somebody talks about weather, about climate. You think as if you know. Nowadays, I think the big challenge many of you know is many people nowadays
Hello?
have introduced the concept of climate through climate change lens. It's because of as many people heard about climate because of climate change, and so because of that there is bias toward saying everything relating everything to climate change. That's why these very basic concepts we need to start with them. How evaluate climate change due to ENSO? I think we will come to that another time. So far, so good for somebody. So where can we download the lecture? I think RuForum will share that information when the thing is ready. I think they will email you the link. Hope we learn something on urbanization and climate change. I cannot promise to go into urbanization, but we'll learn more about climate change, definitely, on Thursday. Do you think spatial interpolation to produce temperature maps? That's a good question. So we will come to that when we look at, bring back that question when we talk about climate data. So I'm looking at two different places, but so about spatial interpolation, we'll come to that, Ronald. So, Gilbert is asking if some variable change and another doesn't change, that you call, of course, if only temperature change, yes, that's climate change. I think we will come to that when we talk about different aspects of climate change. Yeah. How do I speak? Girma says, how do I speak? Just speak, Girma. Unmute yourself and speak. So Girma is talking about some video, which I'm not sure what it's about. All right, so I will give you now 15 minutes break. It's good. Maybe some health breaks. So we'll come back exactly 9:15 or whatever in about 15 minutes. For me, it is 9 o'clock now here in New York. For it could be something else, but we'll be back in exactly 15 minutes, and we will talk about the next one. I think this is for me, this is if you don't follow anything, that would be good to follow this one, the upcoming factor determining climate of a location. I think it is good. It gives you a very good foundation in terms of understanding and defining in a climate of a location, and then trying to understand what makes that climate that way, that kind of thing. So come back in about 15 minutes. Okay, RuForum, that's fine.
Yes, that's fine.
That's okay on my side.
All right, we'll be back then.
Omoni jeudi, à peine plénière et bandi, puis non, bobimi na bino bandi kosaba déclaration libanda. Problème,
Hello, welcome back. So we will continue. My clock says it is 50 minutes after the hour, so I think we are on time. Hope everybody is there. Hello. It seems some people went.
Yes, Dr. Tuf,
Okay.
we are on.
All right. Hello, yes. Okay. Okay, so let's go to factors that determine what your climate will look like. Okay, so first, how do we define climate? I think that makes sense. So here the high-level learning climate classification. How do you classify? Recognize climate zones across the globe and global and local. I think the last point is the main one, identifying the global and local factors that determine your climate, right? Climate of your location, how it determine. So in terms of climate classification, this is the Copenhagen climate classification map. This is for Africa. And you can see the classification. So this is the what, as we say, the special aspect of climate of Africa. I don't think we have any polar frost climate here, but you never know over Kenya and Ethiopian mountains, it might happen. So it goes from all the way arid desert hot on over the Sahara and part of Kalahari, but also tropical rainforest over DRC area, Central Africa. Anyway, so you can see the different aspects, and this is based on mainly rainfall and temperature. This is a more global classification. I just giving you how Africa is classified in terms of this Muzungu's climate classification. So again, so I think this is one thing, but also we can look at is this based on rainfall or, I mean, it's both, but for Africa, which one is the more determining factor for this? Let's compare. So this is the rainfall. So this is annual mean rainfall at actually this is not monthly time scale, but it's annual long-term 30-year mean. And if compare the two, you can see that actually the rain, because for rainfall, light areas are low rainfall areas. Dark areas are high rainfall areas, that pattern. And you can see, I mean, actually the Copenhagen classification is almost matches the rainfall amount for Africa. So you can see the role rainfall plays actually for this kind of classification. Of course, we can also compare, but then can you see, for example, over Eastern Africa, if you look over Ethiopia, so the northern half of Ethiopia is totally different from its surrounding, either surrounding even eastern part, northeastern part of Ethiopia, or western from the Sudan side. You see this blue. What was the blue one, by the way? Tropical monsoon or tropical savanna kind of weather. I mean climate, not weather. And that goes along with the rainfall amount over Ethiopian highlands again. So you can see the impact of rainfall. Of course, you can also look at the temperature. You can see some similarity with the temperature, but it's not as clear as the rainfall. Does that make sense? Do you see the difference? Here is the rainfall and the classification, and here is the temperature to the classification. Again, the Ethiopian highlands, Kenya highlands, you can see again still being similar to the climate classification, but again, it is not as clear as stark as the rainfall. You following me, guys? Does that make sense? Anyway, so it's see how it seems rainfall plays a more significant role in defining, at least in this case, defining the climate of Africa. And of course, if you look at maybe go Europe or Northern Hemisphere, it might be temperature playing more dominant role, that kind of thing. Because the reason is because temperature availability. I mean, if you go now look at the rainfall, how it varies. The spatial variability of the rainfall from Central Africa to north or south compared to the temperature. So temperature, you don't see that much variability because it is warm anyway. So that's why it's good to understand that aspect of things. Hope you are following. And if you want to zoom into, because I mentioned Ethiopia early, and you can zoom into, so you can see temperature, rainfall on the left. Bottom right is the classification, the Copenhagen classification, and of course the top right is Ethiopia's topography, right? And so if you compare the temperature map to the topography, it is really very, very similar. Rainfall has a similarity to the topography, but not like the temperature. And if you compare now the classification to topography, you can see some similarity because the high land areas are greener. So it's a different category compared to the lowland areas as well. But you can see even though the temperature follows exactly topography to some level, rainfall doesn't. Okay, it does, but you can see you see a lot of rainfall over lowland areas all over the western side of Ethiopia, while over the eastern side, actually lowlands is dry. Again, even the classification shows the difference between the two. So, I mean, the reason I want to present Ethiopia is because it is very complex. I mean, you can see how the climate is really complex over this small area. You can see so many climate types. Okay. So another one is, of course, temporal. I think we already looked at this. The temporal, you can look, okay, what happens at different times of the year, or maybe seasonalities for rainfall, for Zambia, again. And you can see Zambia, the rainfall is from December, actually from November. Let's look at a specific location in Zambia. Rainfall starts sometime in October, then picks up November, December, January, February, March. Then May to September is the dry season. This is, again, another way of looking at the climate, again, temporal aspect. We have seen this before as an example of climate variability. So I'm hoping people are, for this anyway, how we define climate, how we say, okay, here is the climate of this location looks like this in terms of spatial representation, but in terms of also temporal representation. And we already discussed spatial and temporal aspect of the climate. So, okay, what are the factors now? Okay, so this is what we said, okay, yeah, rainfall. Why is rainfall over the DRC area heavy and the rainfall over the Sahara very low? Or why the temperature of this location like that and the temperature of another location different? So what are the main factors that make this happen? The first one is, of course, energy, right? I mean, the whole climate system is driven, the climate engine is driven by energy, and that energy comes from the sun. Okay, so that energy comes from the sun. But the distribution of the energy from the sun on Earth is not the same because of the shape of the Earth, right? So there is the cartoon showing radiation, sun's rays coming from the sun over high latitudes. the same amount of energy is spread over a wider area because of the curvature of the Earth. So the energy per unit area is very low compared to over equator, where the same amount of energy covers small area. So that the energy per square area or per unit area is high compared to the high latitude area. So this creates a difference in energy distribution between equatorial areas and higher latitude areas, which means either on the south and on the north. So, and by the way, this is the whole, I mean, I don't want to go into details, but the whole global climate is driven so that nature always tries to balance itself. If something is too much, so one place, nature will try to move it to another place. It is not like people. For people, always rich people keep getting richer and poor people getting poorer, mostly. So that's very unnatural. But in nature, if you have too much water in one place, that water will flow to somewhere else. If you have too much air of one place, it will try to go to another, to a place where it is lower. The same with energy. Because of too much energy around the equator, the nature will try to balance that energy, move that energy to south and north, where the energy level. That is the whole engine that drives the climate in the atmosphere, in the ocean. So this again, what I already said, and this depends on latitude, because so equator is 0 latitude. As latitude increases, the amount of energy that area receives decreases. And because of that, we divide the Earth into some circles. I think you are familiar, right? Then you have the equator, but on the north you have Tropic of Cancer and down Tropic of Capricorn. This is 23.5 degrees north and south, and the 23 degrees because of the tilt of the Earth. I think again we'll come to that later. And then you have the Arctic Circle, both south and north. And because of this, again, energy difference, there is also how we define. There's a different way of defining climate. Remember the ones we defined the Köppen climate that includes uses all rainfall and temperature. But if you just look at the energy that is received at the surface, then there is another way of classifying the climate. So you see the tropics, which is around the equator, then subtropics, mid latitudes, and then polar areas. This is purely based. By the way, this is not even based on the temperature itself, because I will show later. Temperature, the same areas receiving the same amount of areas receiving the same amount of energy could have different temperature. So this is just to show you, based on the energy received at that location, here are how the things are classified. So from all the way from tropics, and then as you go north and south, the energy level decreases. Again, this is what drives the climate. Everybody okay? Ça va? Ça marche bien? No? Okay, maybe. So now, if you compare this to this, you see a big difference, right? I mean, here it is, everything is smooth and flat, but here it is total different. So can somebody tell me why the two are different? Is it two different ways of presenting the climate? But can somebody tell me what makes the two different? You can raise your hand, or maybe I can go to let me go to the comment, to the chat one, because some people go there.
They can write in the chat.
Okay, I write in the chat. I hope you understand the question. So this is one way, come on. This is one way of presenting the climate. This is another way of presenting the climate of the world. What is the difference between the two? Or what makes them look different so much? Due to elevation, as I was saying, due to elevation, just say, okay. Anybody else? Elevation, what else? Vegetation difference could be temperature, yeah, but why? What makes the temperature difference? Or else it's because of temperature difference. But why temperature? Augustine, I think this is what? A result of different projections. No. Augustine is going into map projections. Spatial, yeah, there is a spatial difference, but why the spatial with that comes from latitude? No, because that the first division of latitude. Altitude, maybe, yeah, it could be. Agroecology, maybe it's an effect. Water surface, yeah, okay. I think water surface can contribute some level. No, it's 23.5 that's possible due to temperature and rainfall patterns, I think, yeah. Altitude. Saying altitude, yeah, I mean, altitude means elevation. Elevation could be elevation difference. But also, remember what I said before? This classification is based on both rainfall and temperature. This one is based on temperature, not even temperature, the energy received at the given location. And the energy, like I said, at the same latitude, at the same altitude, they receive the same amount of energy, but the temperature could still be different because of many factors. So, I mean, I think we will come to factors, but here I think the main difference is this one is based on rainfall and temperature, both. The previous one is based mainly on energy received at that location. Otherwise, the Earth cannot be like this smooth across the whole thing. Looking only at the energy, this one, but the impact of energy, rainfall, temperature. But we will come to other factors. I think elevation definitely, proximity to the surface. We'll see that kind of thing. Okay. The other factor is, of course, people already talked about this rotation around the sun, which creates seasonality. Remember, the rainfall season in Zambia is totally different from rainfall season in Sudan or Niger. Or the one in Niger is different than the one in, I don't know, Angola or maybe Cameroon. And this has something to do, again, one of those other global factors. This one is because of the rotation of the Earth around the sun, number one. And number two, how the Earth is tilted. Somebody was saying the 23.5 tilt you see here at the bottom, showing you this angle between the axis of the Earth, right? The axis of rotation, and how the Earth is tilted away from this axis by 23.5. That contributes a lot in terms of seasonality. And this is all because we go back to the energy. So let's start from somewhere. Let's start from on the late June. In summer, northern summer, okay, in northern hemisphere summer, here is the sun here, and the Earth, the northern part of the globe, tilts toward the sun. Okay, it is toward the sun. This is when, because the sun goes between south, 23.5 degrees south to 23.5 degrees north. This is when the sun is at 23.5 north, maximum. That's when it goes to maximum. Okay, on June 21st. After June 21st, it will start going down, and we will come to that later. So here, the northern pole, for example, it gets sun almost for 6, I don't know, day and night. There is no almost night for some time. So a lot of, so the northern hemisphere gets a lot of energy. In September, because the sun has now started moving down from north to south, now it will be over the equator. So this is, I think, when like night and days are the same for many locations around the world. Then we go into northern winter or southern summer. This time, the northern part is tilting away from the sun. So the southern half of the, not half, but the southern part of the globe get more energy compared to northern. And after December, again, the sun starts going up north. And in September, in March, again, it comes to over the equator. So now going back to this one, you see this is, so the sun goes between Tropic of Capricorn and Tropic of Cancer. It will be at Tropic of Cancer on June 21st and Tropic of Capricorn in what, December 31st? Right? What is that? December 21st. So it's about December 21st and June. So those extreme. And in between, it will be, so it will be on equator twice, right? When it goes up, so here, from here to here, in March, it will be on equator, then goes back up, then coming down, it will be here in June. This again, September will be back here. So this area, it's good to know, the sun passes over this area twice. And that affects the climate of that area in different way compared to other parts. So which means climate, southern Ethiopia, northern Kenya, many around the equator are different from those further north or further south. So this is now to show you how the temperature changes with the sun moving up and down. Can you see that? So blue is cold, red is warm. So look at in December it's south. February now it starts going up. The northern start to warm up. June, you see, July, August. Then it starts cooling down. Now, I can ask you one question. If you see the northern half, I mean, northern part of like Europe, for example, the highest temperature, we said the sun will be on 23.5 north on June 21st. But for those people, just looking here, or for those people who've been to Europe or America, for that matter, the highest temperature, when is the highest temperature in Europe or America? For anybody who has seen that, or even here, when is the highest temperature? Again, you can write into the comments. When is the highest temperature in Europe or America? I want to the month, not somebody says just one single month, June, July, okay. Anybody else? Summer, yeah, but which month is in summer? Somebody says July. David is saying July. Biniam again, July. April in Sudan. Okay, I like that one, okay. It's good to know why it's July, Daniel Cross. Samantha, yeah. So why July? Because we said, remember we said the sun is overhead, it's closer to the northern hemisphere, like closer to Europe in June 21st. After June 21st, it's coming down to the equator. So why would that area be warmer or hotter in July? You're right, it's mostly July and August. So why is it hotter in July while the sun is close to that area in June? June, July, August, not Tatak and all that. You have to choose among the 3 months. Now, okay, anyway, let's agree on July. It's on July, but why? Why in July? Okay, now answer why in July? Warming of the water bodies, okay, but we are talking about land, so it's, yeah, maybe that can be true. I think Turi. Ronald says length of exposure, okay. The position of the sun is north of the equator. Yeah, but that's in June. In July, the sun has, July, August, sun has already started moving down. Because the position of the sun, okay. Seasonal lag. What does seasonal lag mean, Samantha? Yeah, I mean the air covers shortwave energy from the sun to heat. Yeah, but so. Okay, Tariku, is Tariku? What? Get high energy. No, high energy is in June because the sun is close. Makoni says snow. Yeah, but snow what? Snow what? What does snow do? Grandma says warming Pacific Ocean. No. Accumulation of Lacerda saying accumulation of energy received. I think Lacerda, is that right? The Lacerda accumulation of energy received. I think that makes sense to some level. I think, yeah. The ground absorbs more heat in June, which tends to. Okay, yeah, I think, yeah, Samantha, that makes sense. So the thing is because yeah, the radiation will be there in June, but the surface, the land, because always heat energy comes from the sun, but heat comes in from the ground. So before the ground hits the air, the ground must heat first. And that energy that comes in June, maybe May, June, whatever, it first has to hit the freezing surface because the surface was frozen during the winter. So it has to hit surface first, and then that surface, once it hits, accumulates energy, like Samantha said, then it will start hitting the air. That is when we feel temperature, I think, anyway. So that is the same for, this is for rainfall, the same thing now. For those people who know this green area, can somebody tell me what this green area, green line, like east to west green line is called? That the rainfall belt, that moves ambit down. Anybody what that belt is it's called? Equator, no. I'm talking about the rainfall, high rainfall band that moves south and north. Tropical rainfall, no. Wet belt. Okay, Rahel, you are right. I think Rahel got it. What is yeah, Moses at Z. Yeah, so that is actually for us. ITCZ is intertropical convergence zone. That is where the air from the north and south converge in one place. And that converging air, creates this rainfall. So yeah, when people talk about ITCZ, this is what people are talking about. Again, so the rainfall follows the sun, not exactly, but with some, again, because surface has to hit first. So in terms of seasonality, again, remember we looked at this already for Zambia. So you can see Zambia during June, July, August is dry because during this time, the sun is the farthest away from Zambia because it is somewhere over northern part, no, actually over Sudan or something. So dry during that season, right? Because it is this, where is that? This June, this season. What am I doing? No. It is this season here. So you can see the rain starts in December or November when the sun is now coming back to the southern hemisphere. So you see rainfall exactly reacting to the sun's movement down. So this is for Zambia, but this is Kenya. Now, Kenya, do you see two different seasons for rainfall? Zambia had only one, but this location over Kenya has two rainfall seasons. Can somebody now tell me why Zambia only has one and Kenya has two? Do you attend, what is this? Okay. Any question? Not question. Answer me. Why Kenya has two rainfall seasons and Zambia only one? Moses says IZ passes Kenya twice because it is along there. Yeah, I think that is the main answer. Because the sun passes over part of Kenya, twice, while going up north and another time going south. And not only Kenya, the southern part of Ethiopia also has the same rainfall pattern. So you can see how the global thing is topography. No, it's not topography. I think what Moses says is right, because topography is something different. By the way, so what we have been looking at so far has been what we call global factors. Okay, and again, there is this difference between Zambia and Kenya because of what's happening here. Because if you see this, Zambia only once is all the way south, but areas close to the equator, you can see twice going up and going down. That's why you see one here, only one season, starting from November, December to ending in March or February, and another one having two different seasons. Another one is, I will come to that, sea land distribution, how sea land is distributed. I didn't finish this one up. I think we will see it in the other lecture. But globally, how the sea, where a country is relative to this circulation, what we call zonal circulation. So there are areas where winds converge over the oceans, raise and give you rainfall. And there are areas where the rising air now descends. This is called dry air descending. So these are dry areas. The one where moist air rises is wet regions. For example, areas like, so this is actually what we call high pressure areas. And normally these are where we call low pressure areas. And areas like the Sahara, most of the time they are under high pressure areas. And high pressure areas are where air descends. So no rainfall, because we will see for rainfall to happen, you need moisture, but also rain. And sometimes this is what happens on average, but sometimes we'll talk about this later. Sometimes this can shift either east or west, disrupting what is normally expected. So for now, I want to stop here and give you another 10 minutes if you have any question before we come to, so we'll start so now we have covered the global factors. Remember, energy balance, the issue of seasonality, and this sea land distribution. So now you have a good idea in terms of how the global factors. So these global factors will happen anyway. So I mean, the air, it doesn't matter if there's climate change or not, or whatever the season, these global factors are always there. But our climate is not the same, actually. Even the same latitude, same longitude will not have the same climate. Then that is where we come to the local factors, other factors that modify this global effect. That we'll cover those tomorrow. Now, any questions, comment, and complaints, if anybody wants to complain about this. Mine says, I'm from South Sudan. Some passes on us too much. He's complaining about having too much sun. Elias wants the presentation. Any question about what your course over? Either you can raise your hand. Thank you, German. Iman. David, of course, wants you guys to sign the attendance. I like Ronald's question. When we say, that's a very good point. The sun goes up and down. That is actually not true, no? Huh? That's a very good point. The sun doesn't move up and down or right and left, actually. Actually, I should have said it is the apparent movement, how it appears somebody on the earth. Actually, it is the sun, it's the earth moving around the sun. It's not the sun moving up south. But apparently for us, we see, what we see is the sun moving north, south, south, north. But that we should say, I should have qualified it as an apparent movement to us, but in reality, it is us moving around the sun, not the sun. So good point. With Samir, thank you, Samir. Any question? I mean, yeah, you are welcome for people who are writing. Thank you. But any questions? Maybe I should go to the question and answer thing here. Okay, I'm from South. Okay, that's but I didn't get it. So even if I get it, the slide, I don't think it will be. Why? Precious saying, Precious. I mean, why? Can you talk about what you're saying? What do you mean? Precious, you're complaining about the slides. What is it? Okay, you can unmute and say something. Hello? Okay, maybe not. Anybody raising their hand?
Hello.
Yes.
Hello, can you hear me?
Yes. Go ahead.
All right. Unfortunately, I think this question came in during the first part of the session when you were defining terms like spatial, something and temporal. So that was the slide that I wanted you to come back to explain, but I think for now, I think maybe it's not relevant anymore. Thank you.
Okay. What is this thing? Spatial, I don't. This one?
Yes, thank you.
Yeah, I mean, anybody can raise your hand if you want, if you have any. By the way, you can ask any question now. We have almost about 10 minutes left now. So anybody either through the Q&A. So I'm not going to look at the comment. I'm looking only at the Q&A. But you can also raise your hand. This is a time to ask any question related to this one. It could be, I don't know, like I said, to anything. But it would be good if you can raise your hands. Can any man-made problem create climate prediction problem like war? I'm not sure. I mean, the war can create climate observation problem, but I'm not sure. Maybe, why not? I mean, if it makes climate observation problem and you need observation for prediction, and maybe. Okay, Makonnen, okay. Anybody else, any question? It seems missing the text part.
But there are some questions in the chat box. They are not in the Q&A. Unfortunately, I think they are using both the Q&A and the chat box.
Yeah, so
Someone is
yeah,
asking about El Nino and La Nina, ITCZ.
so El Nino La Nina will come to that. But the ITCZ is, like I said, it is where wind is converged. Maybe I think tomorrow, let me try to, because we need to talk about pressure, low pressure, high pressure. And I didn't talk about those. That's why I didn't talk much about ITCZ. But maybe tomorrow I can start with that. First talk about what high pressure is, low pressure is, and then how wind is from one place go to the other and convert. So that's ITCZ, where ITCZ is a low pressure area, and wind is come from different high pressure areas to low pressure areas. Like I said, in nature, things go from high to low. So from high pressure area, low pressure area. And by the way, what's the pressure? Can somebody tell me what the pressure is? We talk all the time about pressure. What's pressure? What is it? How many days this training? This training from today until Thursday. So 1 day today, we are left with 3 days. So we'll end on Thursday. 2 hours every day. Next, so we done today, but we have another 3 days. A lot to talk about, including a lot about climate change on Thursday, most probably. Because I don't see any questions. Any certificate of the training that is for Florence to answer? That is Isa asking. I don't know if so. If you want certificate, then I have to give you a test. Maybe you should get that for attending. But this is more than certificate. I think this is for you to use this concept for yourself, but most importantly for your students. I mean, can somebody tell me how for people in this still in on the call, do you find this important for your teaching? So many people are asking about the lectures and then the presentations. Do you think it is important? Yeah, so people reacting saying it's very important.
So we shall do an evaluation at the end of the training, and that will also guide in terms of our assessments and whether the teams, depending on the categories, because we do have the registrations that will indicate the category of participants and how they can utilize the information that you have provided.
Okay, so I see a lot of people saying it is important. It's good to know. Now, my last question is there anything I need to change in terms of my presentation? Any suggestion in terms of, because this is our first day, we have 3 more days.
Yes, Tufa, if you can stay behind, when we close, then we can have a discussion.
Okay. But okay, as from the student, the training side, any suggestion, anything I need to improve? Keep it as is. Okay, somebody you talk too. Okay, somebody come. Okay, Felix says I'm too fast. Not asking for long. Model-based section for this webinar. Model. I will talk about climate modeling definitely, but not to train you on climate modeling, but so that you understand climate modeling. Okay. Okay, Felix still complaining I took too fast. I think that's true, by the way. I talk too fast, so it's good. By nature, I talk too fast. Yeah, so the 3-day will be the same hours until Thursday, 2 hours a day with 15 minutes break in between. So, I mean, in terms of impact, so this is climate basic, so we don't go deep into impacts, but we will definitely talk about some impacts of climate change on Thursday. Okay, so many people say fine. There are some people. Yeah. Okay. Okay, so I didn't see my complaint except the I speak fast one, which is actually I do understand I speak fast. So maintain the short presentation sessions and the breaks. Okay, that's good. And the notes. Okay, thing. Now we will share the notes actually, but not now. We're doing some. Software-based training, we have, I will talk about CDT, but I will not train you on CDT. CDT training by text will take 4 days at least. So, so people are asking for software. Like I said, I will introduce a software for climate data analysis, maybe tomorrow. But I will not give you training on the software because, again, that will take time. There's not enough time to do that. So watch prepared video during the break. I don't know what that's about, but maybe that's a good idea actually if there is prepared video. All right, so I think we are done for the day. Thank you very much. We'll see you tomorrow, same time. Hopefully same energy or even better energy. So Florence, you wanted me to stay on or?
Yes. Oh, sorry. Yes, we'd like you to stay on and we have a small chat.
Okay.
So David, Amitu, if you can facilitate this process, that would be great.
Maybe I have to send you a separate link because now here we can't control how people live.
Okay, then maybe you can do tomorrow, like maybe earlier, like 15 minutes early tomorrow or something.
So you want? No, I think it would be best we do it now because then it guides how.
Okay.
Let me send you a separate link.
Okay, with the Ekepu and Majaliwa.
Okay.
Yes.